Now we have two vectors of ax of I, ay of j, az of k, and the other one's vector b, similar. If we want to add a and b, a plus b, graphically, we know how to do it. Mathematically, how do we do that? Well, you look at this. If we want to add a and b, we have 6 terms. It is the x term, the I term add together because that is the x direction. And then the y term. So if we want to do the a plus minus b, it's simply n of ax plus minus of bx. It is the I term add or subtract each other. And then the j term, ay plus minus by of j, and az plus minus bz of k. It is simply the I term combine either plus or minus j term, k term, and when we express the resultant, we're still in the I, j, k. We still have to describe it, how many units around x, how many units around y, how many units around j, k, z. We cannot mix them. So any vector has to be I, j, k term, cannot mix. So let's take a look at the graph, and I, j, k, as I expressed, right hand rule, if you use your 4 fingers, follow x and it goes to y, and the z term is the sum. So that's I, j, k. These are unit vectors. Now, for a 2-dimensional vector A, it is how many units around x is ax, how many units around y is ay. So if we give something like that, we say a equals to ax of I plus ay of j. If we want to know the magnitude of this vector A, obviously that is ax of square plus ay of square root. If we have ijk, then we have ax square plus ay square plus az square root. That get magnitude. This angle theta, obviously we can do tangent theta, that equals to the ay divided by a of x. We do arctangent, we find the angle. So if they give us components, we can find the magnitude and angle. Then eventually we say theta degree north of east. If this is east, that's north. For 2 vectors add together, look at this A. A has ax this much, ay that much. That's A. See? Tail tip of ax, tail tip of ay, and of A. We have a vector B. B is right here. This is how much the B along the x-axis and how much of by, because B starts from here. So the y is this much. See? This is how much the by. So this is A of y, this is B of y. They have same direction, that's why end up add together. So the resultant R has a total, we named it R of y this much because that is A of y plus B of y. In this case, they add together because same direction, up, up. And x direction, it is ax positive, bx positive. So we end up that Rx this much positive. So that is our resultant R. We just learned that if we have a resultant A plus B, that is the II term, which is A of x plus B of x, the II term, and A of y plus B of y of j term. So graphically, that's what it means. Now, what if we want to add these 2 vectors A and B? Let's take a look. Our A has AY up, AX to the right. What about our B? Our B has a BX to the right, but the BY is down. So if we add it, we have this much of AY add that much of BY. Obviously, we will end up in this much of cancellation. So the resultant will be RY of this much left. And then for the X, because we have this much of AX and we have that much of BX, so our resultant will end up a lot. That is the RX. So I predict my our resultant RYRX. So our resultant will end up like that direction. That is our resultant R. Let's take a look whether this is true or not. As a matter of fact, if you take a look at our A and B are already tail to tail. So we use A and B to construct a parallelogram. And as a matter of fact, the diagonal will be of this much. It's pretty much similar to the one that we expected. We have a lot of Rx. We have a little bit of Ry. So that is the graphical method of representation of a vector plus another vector. Now let's look at a real case of sample 1. John walked on Sunday. The first displacement is 2 kilometers east. The second one is 5 kilometers 25 degrees north of east. The third one 2.5 kilometers 30 degrees south of west. We need to draw a diagram first. So let's have a Cartesian coordinate of this is east and that is north. We have to decide a scale. So look at this is 2, 5, 2.5. Well, let's say 1 of kilometer equals to 1.0 cm. So this will have 2.0 cm, 5.0 cm. This is 2.5 cm. We decide the scale, so we decide the length of a vector. Then we're going to draw 3 vectors. S1 2.5 kilometer east, that's easy because we just 2 centimeters if we have a ruler and 1 and 2, so that is our vector S1. S1, it's 2 centimeters of east. S2 is 5 centimeters 25 degrees north of east. What we need to do is we need to have a protractor, put the center protractor here, find the angle 25 degrees north of east, and then we cut a length of 5 centimeters. So say for example this is 25 degrees. Say that length is 5 centimeters for example. Then that is S2. That is S2. That angle is 25 degrees north of east. Then we have a 2.5 centimeters 30 degrees south of west. Here's the west, 30 degrees south. So we have, say this is 30 degrees angle. 30 degrees south of west is this way. And 2.5 kilometers, 1, 2, we have another half. That is S of 3. So we find our vectors S1, S2, S3. Now, graphically, how do we make sense out of this? John had a walk. So we have to finish S1, then go S2, then go S3. So it actually, what happened is John walked this way. S1, Then the second one is 25 degrees north of east, if 5 centimeters. So you continue to walk, that's S2. This is S1, that's S2. Then if this is the east-west reference, John started to work 30 degrees south of west. So actually he turns around for, if this angle initially, this is 25, for example, if this angle is 25, then if parallel, this is 25, then 30 degrees will have to make a little bit more turn, like here. So it's like that. That makes, for example, 30 degrees. Well, actually, I exaggerated. 25 degrees, not that big. So the S3 is this orange one, S3. So eventually, John ends up here. And what is the resultant? The resultant is from the first, where it start, point to where it end. So this is the resultant, R. John had to walk, this is S1, it's S2, then S3 comes to here, and resultant is that. So, in order to mathematically find out exactly where is John, we need to translate the angle. East is 0 degrees. 25 degrees north of east. We do counterclockwise, it is 25 degrees. But 30 degrees south of west, 30 degrees south of west, it already has 180 degrees from here. Then another 30 degrees, that is 210. So this angle, 30 degrees south of west, is equivalent to 210 degrees with respect to our reference. So mathematically, this is how we do it. Mathematically, that S1 is 2.0 of I, because that is simply east. S2 is 5.0 cosine 25 degrees I plus 5.0 sine 25 degrees J. S3 is 2.5 kilometers as the magnitude, and cosine 210 degrees because that is 30 degrees of south of west, and 2.5 sine 210 degrees of J. So the resultant of S1, 2, 3 actually ends up as 2.0 plus 4.0 of cosine 25 degrees and 2.5 cosine 210 degrees. That is the x component add together of I plus all the y. This one has 0 j turns, so it doesn't have y at all. So y start with 5.0 of sine 25 degree, that one, plus 2.5 of sine 210 degrees of, that is the 2 j turn add together. So this will be our resultant Rx. That will be our resultant of Ry. So eventually, if we ask this question, where is John? We'll say Rx squared plus Ry squared square root. That R is how far away the final position with respect to origin. And the angle, we will do tangent theta as Ry over Rx to find the angle. And eventually, from the graph, we can tell, if you remember, eventually it's something like that, because this is where the initial point and that is the final point. So eventually our angle is something degrees with respect to north of east. That is where is the final position.